So, what we're going to do today is we're talking about solving radical equations. Okay, so that means we're going to be solving, huh? Oh, I know. That's because I typed it up yesterday, and I should have. You're right. So we're going to be solving, but we can leave it. We can leave our. You know what we can do, Tammy? We can just do this. How's that? How's that? Yeah, just do that right there.
Why that way?
So, well, it won't matter. At least you have a column for Cornell notes, right?
But I use it. I don't like those.
Anyway, you don't have to do that. You do not have to do that. So, solving square root. Yeah, solving square root or cube root equations. So the word radical. Rational means fraction. Rational means fraction, but radical means roots. Okay? Not like the roots in graphing, but like square roots, cubic roots, fourth roots, any kind of a root. Okay? So when you solve these, you have to at least think about the domain, right? So for example, inside of here can't be negative. You agree with that? We cannot. Square root of a negative number can't be done. It'll give us I answers. We aren't going to have I answers. We want real answers, okay? Square root of negative numbers, no way, okay? Can't do that. We're not going to do that, okay? So I know right off the bat that x has to be greater than or equal to negative 1, okay? Just think about that, okay? No matter what, I know for sure that x has to be greater than or equal to negative 1. Because if it's equal, actually I'm wrong about that. I am wrong. I admitted it on camera. X to be greater than or equal to. Has to just be greater than. Because it can equal negative 1. It can equal negative 1. Because negative 1 plus 1 is 0. And there is a square root of 0, right? So that's okay. But it can't be negative 2. It can't be negative 2. Because I go to negative 2 plus 1. Right? Negative 2 plus 1 is square root of a negative number. Right? I'll just show it up here real quickly. See, let's for instance negative 2. It'd have the square root of negative 1. That's, an I. And we're not going to do that. Okay? So we know for sure that any answer we get, if it's not greater than negative 1, we're going to have to throw it out, okay? So let's do this, okay? Let's go ahead and solve it. So I'm going to solve like I always do. First step, divide by, or I'll put over here 2 square roots of x plus 1 equals 14. Let's just solve, right? Divide by 2. Everybody agree? Divide by 2, divide by 2. So I'd have the square root of x plus 1 equals 7. How am I going to get rid of the square root? We always do the opposite operation, right? So I'm going to get rid of the square root by squaring both sides, right? Because the square root would cancel the square. And we know that also because this is like a 1/2 power. We learned that the other day. And the 1/2 power of the 2 just cancels it out, right? So then we have just x plus 1 equals 49, right? Minus 1 minus 1, x equals 48. Now, I always like to check it. I think I'm going to do it. We can check in your mind. You can check in your brain. But I'm going to check it real quickly, and I'll show you how you check. I can go 2 square roots of 48 plus 1. That's going to work, isn't it? You agree? We're going to get 49. 7 is 2, okay? That's my check. And the only reason we check is if we ever have a problem right here. If we get a negative inside of here, we're going to throw that answer away, right? Does that make sense? Okay. All right. Example 2. We learned yesterday that cube roots can be positive or negative, right? So, for example 2, there's no restrictions. No restrictions on a cube root. Cube roots can be positive. Remember our graphs yesterday? Cube roots had negatives and they had positives, right? So there's no restrictions, so we're just going to solve this. Well, let's solve it then. Let's divide by 5. Divide by 5. We'll do the cube root of 4x plus 3 equals 3, right? Let's undo the cube root by doing what? Cubing it, right? Cubing it, right? We're going to cube it. Cube it, right? And so then I'm going to have a 4x plus 3 equals 3 cubed, which is 3 times 3 is 9 times 3 is 27, right? And then minus 3 out of 4x equals 24. Divide by 4, x equals 6. And again, I don't need to check this one because there are no restrictions, okay? There's no restrictions because cube roots can be negative, right? So we're good, okay? All right, example 5. Well, for sure on example 5, I better not have any negative answers, okay? Right? No negative answers, okay? You guys agree with that? So on number 5, x cannot equal a negative number, okay?
Wait, how do you know when it can be no restrictions?
Great question. Cube roots, no restrictions. Square roots, restrictions. Does that make sense?
Yeah.
You can take a cube root of a negative number. You can, but you cannot take a square root of a negative number. Good question, okay? So cube root, no restrictions. Square root, oh yeah. Okay, so I know for sure that if x is negative, we're gonna have some problems, okay? So let's go ahead and solve it, okay? So first of all, if I square both sides, I gotta be a little careful here. I gotta square the entire thing. So I want you to think about how I'm gonna do this. The square cancels the square root, right? So boom, 35x. That's easy. But on the second part, the 5 is going to get squared, right? The 5 is going to get squared, so I'm going to get a 25. And the square will cancel the square root, so I'll have an x plus 2. You with me? I had to square the 5. I got the 25. And the square cancels the square root, okay? So far, so good? Okay. That times that, right? That gets easy. 35x equals a 25x plus 50, right? Minus 25x minus 25x, 10x equals 50. Divide by 10, x equals 5. And that's okay because we said the restriction was no negative numbers, so we're good. 5 will work, right? 5 will work. Take it, okay? Okay, pretty easy. Pretty easy. Okay, now the next one is the one I like because the next one's going to take us and make us think. 4 and 5 are going to be the thinkers, okay? So let's take a look at this problem. I'm going to get rid of the square root by squaring both sides, right? Square that, and I got to square this side, right? Now, we're going to remember a little side work. We're going to remember that x minus 2 squared is the same thing as x minus 2 times x minus 2, right? It is not, and I'll write it up here, it is not x squared minus 4. It's not, because we're going to get a FOIL problem, we're going to get a middle term, right? So we're going to have to get a middle term. So let me do that. I'm going to go ahead and go through and go, all right, x squared minus 2x minus another 2x plus a 4, right? So it really becomes an x squared minus a 4x plus a 4, right? So that's what I want to put here, equals x squared minus 4x plus 4. Okay? And the square cancels the square root, so just x plus 18, okay? I'll stop and let you catch up, okay? So I squared both sides, right? Mm-hmm. The square canceled the square root, and on the other side it became a FOIL problem, right? Okay, now this looks like it's one of those F words again, factor, right? Can you see how this would be a factoring problem? Okay, so let's bring over the x, we'll go minus x, minus 18, so I got 0 equals x squared minus 5x minus 14, okay? Okay. So, factor, right? Parentheses. X and x. What times what makes 14? Yeah, in fact, let's use a negative 7 and a positive 2, right? And that will give us our negative 5. Now, these are my mini equations. Remember, mini equations. So I got my minis. My mini equations, which means then basically x would equal 7 and x would equal negative 2, right? Little mini equations, right? If I set... smart girl. You are an A student. Yes, you are. You can't have negative 2. Now, why not, Tammy?
Because it doesn't have a 3.
If you plug in negative 2, right? Let's go back and check it. So, Tammy, let's just say Tammy's right. Let's just say Tammy's right. Could we check it? Sure. Let's prove why Tammy's right. So, we go back to the original, right? Okay, let's prove why she's right. So if x is negative 2, we'll check it. We'll have square root of negative 2 plus 18 should equal negative 2 minus 2, right? Well, first of all, square roots can't equal negatives. They can't. But I'll go further. I'll get the square root of 16 equals negative 4. But is the square root of 16 equal negative 4? No. So nice job, Tammy. We throw that away. The 7 does work, but you can check if the 7 does work. Nice job, smart girl. There you go. All right. Now, example 5 is a little bit tricky because there's going to be a range of answers. If we were to solve it like we normally do, let's just solve it like we normally do. Okay, make that an equal to though, less than or equal to. Makes it easier to make it an equal to. I meant to make it equal, and I was in a hurry, so that's what happens. I forgot to put that in there. Anyway, square it, right? You guys agree? So I got a 2x plus 4 is less than or equal to 16, right? Minus 4, 2x is less than or equal to 12, right? Divide by 2, x is less than or equal to 6, right? Not exactly. X is less than 6 is a lot of numbers, isn't it? It's a lot of numbers. Well, does that mean x could equal, say, negative 10? According to this, it could, but what happens if you put negative 10 in here? It can't be. Could x equal negative 4? No. So what I want to do is this. I take what's inside my 2x plus 4, right? And I want to make sure that what's inside is never negative. Never negative. So I say, okay, well, let's make sure it's greater than or equal to 0, okay? Are you with me on my thought? I want to make sure that what's inside here never becomes a negative. So I say, okay, let's take the 2x plus 4 and make sure it's greater than or equal to 0. So let's solve for x and find out what values would work. Okay, so if I solve for x, minus 4, I'd have a 2x is greater than or equal to negative 4. Divide by 2, x has to be greater than or equal to negative 2. Okay, now that tells me this. It could be negative 2. It could be. And it could be negative 1. Because think about it, negative 2 would give you a negative 4. In fact, I'll show it on the board, okay? If it's negative 2, you with me? If it's negative 2, I'd get the square root of a negative 4 plus 4, which is 0. That's okay, isn't it? That's okay, right? It could even be a negative 1, right? Square root of negative 1 could be negative 2 plus 4. Okay, that's fine because it's still less than 4, right? But it can't be a negative 3. Because if it's a negative 3, I'd get a negative 6 plus 4. That's not going to work. So I'm going to say make sure that my answers are going to be bigger than negative 2, but less than 6. So you get a range of values. Okay, so we're going to say this. We're going to say that we're going to let x be between negative 2, has to be less than or equal to x, which is less than or equal to 6. And that would be my answers. Okay, now, real quickly, wouldn't it be cool if you could kind of see this on a calculator? You can. Okay, let me show you how you can see this on a calculator. So if I were to put this on a calculator and graph it, okay, clear, and if I go my square root of 2x plus 4, okay, and I graph 4, okay, I want you to see this. You can't see this. I want you to see this. It's kind of cool how the calculator will show it also. Graph them both, okay, boom. Okay, I might need a better window. Let's get a better window. Alright, let's make sure this goes to, say, 7, okay? And this could go negative 3. There we go, graph it. Okay, now if I look at the calculator, where is it less than 4? It's less than 4 from here to here, isn't it? It's less than 4. Here's 4. It's less than 4 from negative 2 to here, which is 6. And beyond 6, it goes above it, doesn't it? So that's a graphical representation of what the answer we just got. Okay, all right. Let's push pause.